This is Mr. Richmond, and for this video, I'm going to walk you through how to complete slide number 3 for your most recent ClassKick assignment on ions, isotopes, and nuclear symbols. So let's go over this first example. I have element symbol Na. That's got to be sodium, atomic number 11 on my periodic table. In a neutral atom, which means that the amount of protons are equivalent to the amount of electrons, the amount of positives are canceled out by the amount of negative charges. This tells us that we have 11 protons and 11 electrons, the atomic number that is. The amount of neutrons, you should know this by now, I calculate by rounding the mass to its nearest whole number to 23 minus 11. That gives me 12 neutrons. So in a neutral atom, I have 11 protons, 12 neutrons, and 11 electrons. I drew this for you up here. It's not all that pretty, but I put 11 positive charges, 11 protons are canceled out by 11 negative charges or 11 electrons. So this is what your neutral atom looks like. If you were to draw a Bohr model of sodium, you would end up with 1 electron in the outermost energy level. So you should know by now that sodium, just like you did on the previous slide, sodium would love to lose that 1 electron. It would be a lot easier for sodium to lose that 1 electron rather than to gain 7 to achieve its octet. So if sodium were to do that, which it prefers to do, I would go ahead and erase this 1 electron to determine my overall net charge. I have 1 more proton compared to the amount of electrons. So I'm going to go back into my drawing tool and write in element symbol Na plus. There's no need to write a 1 here just by having the plus. We're assuming that's overall charge of plus 1. Just like if we had a negative, we're assuming negative 1. If you did go ahead and write 1, I would not take off any points for that because it's still correct, but just know that it is redundant and there is no need for you to write plus 1. All right, I hope this helps with the rest of your example.